Kinetics is like conceptual, but obviously that's what they like to ask conceptual questions a lot on the multiple choice. But the free response, of course, would be more calculator active, so we would be able to use some of these linear regression equations, including time and concentration differences. So you saw a lot of heavy calculations in the backside of this. So make sure that you feel comfortable with each one, but who knows what's going to appear on our exam. So we just go be comfortable with everything, okay? So we have this equation. I just uploaded the PDF of this. The Word file chopped out some images, but I did put that under homework if you're going back to look at some of those. So we have these graphs. What's most significant about the first graph, second graph, versus third graph? The linear line is what we like to have. So anytime we have a linear relationship, that means that relationship is able to be put into a linear regression equation, y equals mx plus b, which we have lots of equations for to be utilized within kinetics. Okay, so here's your point values, okay? So here's where you would add your points. For the given data, determine the order of reaction with respect to ethanol. It is zero order. That's not a point. Okay, it's zero order plus your explanation. The plot on the left is a straight line indicating the rate of decrease with respect to ethanol's concentration is constant as the ethanol concentration changes. Normally, like just in a normal instance, for example, first order, if you decrease concentration of something, there's less collisions. Therefore, the rate would slow and slow and slow and slow and slow. That would be a first order reaction. So this is like this. I like this last statement. Therefore, the rate of reaction does not depend on the concentration of ethanol. That helps us see the rate law better when we indicate it as first order or as zero order. There's no concentration in the rate law. Period. So 1 point for justification or with justification. Then you got 1 point for the rate law being literally just rate is equal to little k. Remember, little k is how we indicate the rate law constant in kinetics. If you put concentration of ethanol to the 0 power, of course, you would still get your credit because you're indicating that it's irrelevant to the rate of reaction. You were provided with, you were provided with data via a graph, so you have to determine the rate constant. So the rate constant is asking for k. If you're asking for k for a graph like this is the what? It is the slope. Okay, so k literally is always the slope in any of our linear lines. So like k is the slope for zero order in this graph, but if the first order graph were linear, it would be the k. If the k would be the slope. If the second order graph were linear, k would also be the slope. So k literally will be the slope in any of the linear regression lines. But with this one, you had to take points provided. So I did the same one they did, but the two initial, or the initial and the final point values are what I took because they were pretty clean points to look at. And then provided that you understand a slope is change in concentration over change in time, our value for a k value will itself not be negative. The k value itself will not be negative, ever. Okay, so you need to note that for yourself. The slope can be negative. You guys picking up what I'm putting down? But the k value will not be negative. Okay, so despite the fact that ethanol is decreasing in concentration over time, and there's a negative out front to indicate that, we will not express the k value itself as negative. So you got 1 point for setup, because obviously you do have to do a little bit of math for the slope, which was the concentration final minus the concentration initial, and then the elapsed time was 2,000 seconds minus 0 seconds, which gave you an overall 2,000 second change. So that was 2 points. And if you can't read that, that's 4.0 times 10 to the negative 6, and meters per molarity per second. I think I just pulled it up. Okay, so anytime you have rate, it's always concentration change over change in time. So every single rate, zero order, first order, or second order, the final rate itself will be expressed in molarity per time. In this case, this was seconds. It could be hours or days. Okay, so the pressure initially was just ethanol. You guys don't have that reaction from you, so it was just ethanol, and the copper catalyst allowed for it to degrade or to be decomposed into two gases. So it says completely, so we're just assuming that's limiting ingredient, so it's going to be 100% wiped out. So if we have a 1 to 1 to 1 ratio, essentially we're taking 1 mole of gas, producing 2 moles of gas, so we take a 0.4 atmosphere pressure and make a 0.80 for sig figs. So we got 1 point for indicating the correct final pressure. It does not say explain, right? So we just put 0.08 or 80 atmospheres. We were good. But I like, we understand it's a ratio perspective. No crazy gas loss here. So how many points were this? 1, 2, 3, 5. So put, 5 out of 5, 4 out of 5, 3 out of 5, whatever you got up there on that FRQ. Did I go too fast? Give me a thumbs up if I'm good to move. All right, so the next one is a little shorter. No lies, it's not shorter. It's the second half of the question. So as you can imagine, they like to blend FRQs. So this first part may have been a gas law question. The second part is kinetics question, or it could have been equilibrium and then kinetics. So it feels like, we're going to see some cross-curricular action here. All right, so when I was reading this question, first thing I said was I need to circle first order because they already gave me the answer. I already know a lot about this information, about this reaction now. It gave me initial mole sample of ethylamine. It gave me a 2-liter container, 20 minutes, and that's the final concentration after 20 minutes. That's the final concentration. Notice that's moles per liter after 20 minutes. The initial data point was a mole. That's a big difference, right? Especially with kinetics, and we're talking about concentrations. So the rate constant, we're looking for what? Little k. Okay, so the rate law constant is what we're looking for. So given the first order and given these kind of data, what kind of solution process do we have to approach? What do we have to use? That equation. Give me specifics here. Differential rate law or integrated rate law? Integrated with time, right? So we're using the first order integrated rate law with time. What if you have a brain fart and you're like, oh crap, I forgot it? It's on the reference table. You can't forget it, okay? So it's literally right in front of you. They like to use first order a lot because they provide that data, that information for you. They want to know that you know how to apply concepts, not always memorize everything in the book, right? You should have some things memorized, though. Okay. So this was a 3-point question. 1 point for actually finding the initial concentration of ethylamine. They provided you with moles and 2 liters. You had to do the math on the concentration. So even if you didn't literally find the concentration, you just set it up like this, that's totally fine. You got 1 point for setting up the first order integrated rate law, which is using the ln final minus ln of the initial concentration is equal to negative kT, and plugging in that information accordingly. 1 point for the calculated result with units. So the K, the rate law units are pretty important. Don't forget to cancel, cancel, cancel. One thing to note is whenever you have you can always double check it, but if you have a linear regression or natural log and you have ln of concentration minus ln of concentration, what happens when you rearrange according to natural logarithmic like relationship laws? What is this law? Say it again? Right, so because when you subtract natural log or log, what is it really, what can you reorganize that to look like? Division, right? So anytime you have log of x minus log of y, it's actually log of x over y, right? That's the rearrangement for algebra 2, whatever you guys did. So concentration would be divided by concentration, hence canceling concentration. So concentration will not be in your final unit answer. But if it's first order, guys, right? Rate is equal to k times x to the first power. Right, that's rate. What unit does rate have to be in? Molar per time, right? Whatever this is, I think it's seconds, right? No minutes, okay. And then K is our question, and if concentration is in molarity, there's only one thing question could be. It has to incorporate time and nothing else. So you can easily figure it out from a differential rate law versus an integrated rate law if you get confused on the units. But kinetics always gives you points contingent upon your unit, okay? Yeah. This is called the differential rate law, or just the rate law, and then this is called the integrated rate law because we integrate with time. Okay. And I have a big, probably 6-page list of formulas that I'll just show you guys before the exam, just if you forgot something or what it's called. Okay. Given when it says calculate the initial rate, so it's kind of what you're asking. When you're finding the initial rate, that literally means rate as in rate is equal to K times concentration initial. So you use the information provided, plug it into the differential rate law, and solve for rate. So initial rate is rate, like we have up here. K is the K value you just found. So if your K value is wrong, totally fine. You should get points for this one, incorporating it correctly. And that's our initial value as moles per liter. Again, you had to self-calculate that, and then you got 1 point for your calculated result. And this should make sense because rate is always concentration per time, or molarity per minute here in this case. And there must have been 3 sig figs the whole time here, so we're sticking with it. Thumbs up when I can move on. That was your one that you can see, but if it's 1 over concentration, what kind of order is it attempting to graph? Second order. Would it be curved or linear? Curved because it's not, well, because it's not second order, right? This data is not a second order linear regression correlation. So the plot, so you got 1 point with an explanation, right? So you did have to give it a little bit, but the plot would produce a curve. Had the reaction been second order, the plot would have been a straight line. It's not, because the plot of natural log of ethylamine versus time would yield a straight line, which we don't have a graph for that, but we know that first order should be the straight linear regression. And that was 1, 2, I think a 5-point question as well. So write down how many points you got out of 5. And then pull up that big PowerPoint. Go to big idea 3. So if you, I'll just kind of give you the preface of what we're going to do here for the last bit. I have a education.com link with Kinetics multiple choice on it. There's a lot of good multiple choice out there, but sometimes it's not like College Board specific. So obviously you guys have some review books. You've got Princeton, you've got 5 Substitute 5, you've got Barron's, you've got whatever. I'm going to not do this right now because I hear something about capstone tomorrow. So I'm going to let you go ahead and do as much of Big Idea 3 as you can in the next 35 minutes, which should be maybe half. And you'll notice for homework it says begin Big Idea 3, and then tomorrow's homework is to finish Big Idea 3 PowerPoint. So whatever you get done in class, of course you can do more at home. But if you have something else pulling you in a different direction, you've got the time to do it, okay? Something, I'm not sure what it would be. But hey, during intervention today, you better be ready. We're finishing those daggum midterm FRQs that we have been just waiting to do. That means you're presenting something in intervention. We'll get to that shortly. So you work on Big Idea. It's been a while. It doesn't matter. You still know your stuff. You still know your stuff. All right, so be quiet, leave